Let us now get ready with a test on limits and continuity. In this video, I am going to discuss with you more than 10 questions from previous test papers. We will recall the concepts learned, connect them to the application questions, and then see how do we solve examination style test papers with my bright student Akshit. I hope it is going to help all of you. Our approach, engaging minds, help us to perform much better. We can now connect to context, visualize strategy, apply learnings, and bridge the gaps. Engaging minds help in creative thinking and problem solving. Gain the confidence. Get ready for future. We develop both mathematical and social skills. I can be part of your success story. Build strong foundation and ensure bright future. That is the gift of education. You can always contact me on the email address given. Join my classes. Let us now enjoy this interesting session with Akshit. Hi Akshit, how are you doing?
Hi, sir. I'm doing well. How are you?
Very good, very good. So today, what do you want to do?
Sir, tomorrow, since we're done the first unit of calculus, I actually have my first unit test. So I was hoping we can conduct a mock test.
I will, surely. So I'll give you the questions. I'll write them down for you. I may even read them from the book or my previous test papers, which I have. So I have about 10 years of test papers with me, and I'm going to use those questions which normally come in the test in today's lesson. So it will be a mock test for you as you really want. Let me just share
Yeah.
with you a whiteboard. And if you have any difficulties, we'll skip that question, come back to that again.
Yeah.
Similar to what we normally do in a test paper. Does it make
Right.
sense to you?
Yes, sir. Sounds good.
Great. So we have our white screen. I really, appreciate you taking online mock tests from me. And since I know you, I also know which topics, how I have covered, and which could be difficult questions for you, right?
Right.
Mainly because I haven't really taught you those questions, but those are the few gaps which I think I will cover during this mock test also. So don't get
Yes, sir.
surprised when you get some questions from me which you never did before. Okay.
Yeah.
So let me give you the very first question, which could be difficult for you, right? So we have a sequence and you need to find the limit of the sequence, right? So I know you
Yeah.
haven't done the limits of the sequences and series. So we'll begin from a surprise, good question from you, which is seen in many test papers,
Yeah.
in spite of the fact that this topic is not normally done in MCV for you. Okay.
Yeah.
So let us say we have the sequence which is 0.7 and the numbers are like 0.72. It is from a previous test paper, so I have the values written here.
Yeah.
Okay. And basically, it is growing like this 7272, right? So you see how it is growing. And so if it grows till infinitely large number, right? So then in
Yeah.
that case, how do you approximate this limit? So what is the limit of this function? Let us say that's your sequence as uh, uh, it approaches infinitely large number, right? If it just continues like this, you get my point. So I
Yeah.
write 0.72 recurring. So when I write 0.72 recurring, it means it repeats forever. You get the idea.
Yeah. Yes, sir.
So can you tell me the answer of this question?
Yes, sir. I think it's asking for a limit, right? To state a limit for the sequence.
Yeah, but I want you to give me the exact value.
Oh, okay. Sir, I was thinking if we let n represent the number of repetitions, right? The limit would be n approaches infinity.
Okay. So for this sequence, let me, because I know I haven't taught you this. So let me just tell you how we will do it, right? To begin with,
Yeah.
okay? It's not fair to give you that question, but I just, thought it might come in your test, right?
Yeah.
So this is basically writing a decimal repeating number in rational number form, which is P over Q. So you know this value x, let x be, we'll say let x be equal to 0.72 repeating. Do you understand?
Yeah.
In that case, if I multiply both sides by 100, I get 100x equals to what? It will be 72.72 repeating, right?
Yeah.
Now, if I subtract one from the other, that is 100x minus x, then it is how much? It is 72.72 recurring minus 0.72 recurring, which is 72, right?
Yeah.
And that means 99x is equals to 72 and x equals to 72 over 99. So we have an exact value of this number in which it is repeating, right? The decimal repeat. And therefore, we also will learn later that this is basically a rational number.
Yeah.
So it finds huge importance when we talk about rational and irrational numbers. And we also have irrational numbers. So basically, when we talk about irrational numbers, then irrational numbers are numbers which cannot be written in the form of P over Q.
Yeah.
So, for example, square root of 2, right? Square root 2, you cannot write in the form of P over Q. But any number with repeating decimals is a rational number which can be written in the form of P over Q, which is a rational number. You get the idea.
Yes,
So,
sir.
so when this number is repeating the decimal value, it's like growing, right? The number is increasing.
Right.
So it goes forever. So those are the rational numbers, and the technique to write those rational numbers uh, from their decimal equivalent to exact values just shown here. Is that clear to you?
Yeah.
So when you really, if you just on a calculator, check 72 over 99, check what you
Yeah.
get. You get 0.727272 repeating,
Yes.
right?
Yeah.
So that's what I meant. Is it clear to you?
Yes, sir.
So understood this concept?
Yeah.
So let me just clear the screen and now go to the question number 2. Now that is the normal question in a test paper. You need to find the limit of the function limit x approaches 2. So we have this function as absolute value of x minus 2 divided by x minus 2. You have to show that
Yeah.
the limit does not exist. That is your question. You don't have to
Yes,
find,
sir.
I'm telling you that the limit of this function does not exist as you approach 2. So this is basically a communication and thinking question for you.
Right.
So can you explain why the limit does not exist and you need to show me? Tell me how will you do it?
Yes, sir. So, first of all, the limit wouldn't exist if the left-hand limit is not equal to the right-hand limit.
Correct?
So this is definitely the case in this scenario. And if we actually split the function into a piecewise form, then we can see that one side approaches -1 and the other approaches 1. So that's why the limit would not exist when x approaches 2.
Very good answer. So one side approaches -1 when you go to the negative side, the other one approaches +1. And since these two limits are not equal, limit does not exist, right?
Yeah.
So why this one side exists is one, because you say the absolute function, absolute value of x minus 2 can be written as minus of x minus 2 when
Right.
x is less than minus 2, and is plus of x minus 2 when x is greater than equal to minus 2. That's what you're trying to say, correct?
Yes, sir. Yeah.
Perfect. And you have also added very good point here to get all marks of communication marks, which is the limit from both the sides of this particular function. Let me write f of x is not equal to the limit of this function when approaching from the right hand side, correct?
Yes,
There
sir.
is
Correct.
no harm in giving a graph of this particular function also. So can I add a graph here?
Yeah.
Yeah. So when I sketch this particular graph, we know on this side, when x is approaching 2, that is, oh, sorry, it was approaching 2, I wrote minus 2. Approaching 2, right? The question is 2.
Yeah. 2.
So when it is approaching 2, then on the right-hand side, we have a constant function, and on the left-hand side, we have constant function at plus and minus 1. You have to show very clearly that at both these points, we have actually a hole, right?
Yeah.
Because the restriction is that denominator cannot be 0, and we have a restriction that x is not equal to 2, right? So
Right.
even though we have written here greater than equal to, that is how the absolute function is being defined. But in
Right.
this particular case, there is a restriction since the denominator will be 0. So that is a hole, right? So that is
Yes, sir.
how you're going to actually sketch this particular function and get full marks of communication. Is that clear to you?
Yes, sir. Yeah.
So let me clear this and ask you another question. And that question is also a communication question for you. Question number 2, 3, right? So now the question is that provide an example
Yeah.
where the function is discontinuous, but the limit exists. Yes.
Yeah.
Give me an example.
Yes, sir. So we can take something simple like a whole discontinuity, right? For x squared minus 1 over x minus 1.
You had a very good point there. Whole discontinuity. Yeah, example.
X squared minus 1 over x minus 1.
X minus 1. Surely. That is an excellent example. And as since you're saying that, you know exactly what you're saying, you mean this, right?
Yes, sir.
Since
Exactly.
we have a common factor here, they really cancel out. So this is equal to x plus 1, where x is not equal to plus and minus 1, right?
Right.
And in this function, when that is the question to explain, you can always draw a line at x plus 1, which is and discontinuity at plus 1, right? Because that plus 1 factor
Yeah.
cancels, right? So it is like this. So limit, what is the limit of this function as x approaches plus 1? Tell me.
2, sir.
2. Perfect. So limit as the function approaches 1 is 2. So basically the limit is where the function is approaching, not exactly being there. But if it is
Right.
same as the value of the function, then the function is continuous at that particular point.
Yeah.
Beautiful. So that is perfect. So let me clear the screen and then ask you question number 4, please.
Yes, sir.
So the question number 4 is that we say let, oh, sorry. So it is based on fish population. I will
Yeah.
give you the equation. It says the fish population in thousands.
Yeah.
Oops. Wait. I don't know how it went to the screen. I don't know what happened. Okay. Now we are back here. So fish population in thousands is given to you at at time t in years, and is where t is, you can say, greater than equal to 0. So I'm writing in short form. Is it okay?
Yeah.
So the fish
Yeah.
population p of t is given to you as a piecewise function equals to 3 plus 1 over 12t square, where the value of t is between 0 to 6. And then all of a sudden, it changes to 2 plus 1 over 18 t square when it is from 6 to 12. Sorry. Correct. Now, in this particular question, you need to sketch the graph, first part.
Yeah.
And then you need to find the limit x approaching 6 for the fish population.
Yeah.
And C is you need to find how many fish were killed. How many fish were killed? The population actually decreased because of an oil spill, right? So,
Yeah.
so what caused this change is the oil spill.
Yeah.
So how many fish were killed? That is what you need to find. And then part D is when did the fish population recover to the original level?
Yeah.
Level before spill. Yes. Can you do this?
Yes, sir. So initially to sketch the graph, we see that there are two parabolas, right? And
Yeah.
I can tell that I think there will be a discontinuity at t equals to 6, jump discontinuity.
Right.
So based on that, I can sketch the graph.
So better to find part B first. What is
Part
the
B
limit
first, yeah.
of the fish population as approaches 6? So let's find the limit if it exists, right? So let's
Yeah.
find the limit from the both sides. So can you tell me what is the limit?
Yes, sir. From the left side, it would be from the left side, it would be 6, sir.
So you have to use the first equation, right?
Yeah.
So it is 3 plus 1 over 12 times 6 square, which you calculate and tell me. And from the right side is how much?
From the right side, I got 4, sir, as the entire limit.
So I'm writing your values, hoping that they are absolutely correct, right? So 6 for the first one you're saying, right?
Yes, sir.
36, 36 goes 12 times 3, and 3 plus 3 is 6, perfectly fine. And the next one is 4. So the limit is different, and therefore this limit does not exist, right?
Yes, sir.
So the answer for B is does not exist because the left side, right side is not equal. So now it's a question of sketching the graph, right? So, so let's say that's the graph we're going to make. So the discontinuity really happens at 6, right? So let's say this part is 6 for us. So when t is 0, then in that case it is 3, right?
Yeah.
So when t is 0, it is 3. And so it's a parabola, as you're saying. So when t is 0, it is 3. It goes up, but it starts from 3. And it is a parabola which is rising to a level, let's say like this. Is it okay?
Yes, sir.
3 to 6. And as soon as it hits, the oil spill hits, it goes to 4, right?
Yeah.
And then we want to find the time when it is 6, basically, correct?
Right.
That's the next part. So can you figure out what is that time? How much is the 6 now? How many fish were killed? So that gives you the answer. How many fish were killed? Can you tell me the answer for that also?
2,000 fish, sir.
Perfect. So it is in thousands. So 2,000 were killed. So these values are in thousands, correct?
Yeah.
Correct. So now when will it be, when will it reach this level of 6? Then calculate it.
Yes, sir. So you would plug in 6 and then equate the second piece to it, right?
2 plus 1 over 18 t square, you're right. So minus 2, so you can just calculate and tell me, right?
Yeah. Yes, sir. I got roughly 8.48.
You got 8.48. This happened at 6. So basically, let's say it also goes here at roughly 8.4. Right. And the time is in years.
Yeah.
That is perfectly fine. That's an excellent solution. It's a very common question which is seen in almost every year, some school or the other
Yeah.
when I teach, but this is
Yeah.
a very common question. Good, well done. Now I'll directly take questions from the previous test papers, which I do have online also. So I'll
Yeah.
stop sharing the whiteboard, but I'll share with you mm, the YouTube channel where we have those questions
Yes, sir.
already for you. Okay, so maybe this one. Correct. So do you see a question here? Question number 7, please.
Yes, sir. I can see it.
Okay. So tell me, how will you answer this particular question? Read and answer.
Yeah. So question 7. A quadratic function is given by f of x equals x squared plus bx plus c, where b and c are constants. F of 1 is equal to 2, and the slope of the tangent at x equals to 2 is 12.
Correct.
Find the values of b and c. Use limits in your solution.
Correct. So can you please do it?
Yes, sir. So since we know that it's quadratic and b and c are constants,
Yeah.
we're given point p as 1 and 2 because
Yes.
f of 1 is equal to 2.
1 point is
And
known
then
to you, 1 and 2. Good. Yes.
and we're also actually given another point, 2 and
Yes.
12.
No. And the slope of the tangent at x equals to 2 is 12. So we are given the slope the of the tangent rate of change at 2, right? Not 2 and
Oh,
2,
okay. Yeah, yeah,
right?
yeah.
So you have to find the rate of change of this function using difference quotient method and
Right.
equate that to 12. And so you once you find the rate of change, then you'll know the value of the function. Is it okay?
Yes, sir.
Because the function is x squared plus bx plus c. So that means that there are two unknowns, b and c, and the question is saying find the value
Yeah.
of these unknowns, correct? So
Yeah.
you're right, you have to do difference quotient method to find the rate of change, equate that to 12, and then you get two equations, and now you can easily solve the question, right? So
Yes, sir.
yeah, so you can definitely do it. So you go through the solution as such. As you were saying, point 1 and 2 is on the graph. So on the left-hand side of the solution, you know that f of
Yeah.
x is x squared plus bx plus c. When you substitute 1, you get 1, 2 equals to 1 plus b plus c. So first equation is b plus c is 1. Now the
Yeah.
second one is we are given the rate of change 12 as we approach the point 2. So you can use this formula or difference quotient that limit h approaches 0. F of 2 plus h minus f of 2 divided by h. And in this equation, when you substitute 2 plus h for x squared plus bx plus c, and then minus 2 square minus 2b plus c, you can simplify as shown here, correct?
Yeah. Yes,
And
sir.
this is equal to 12. You can cancel the terms 4, and
Yeah.
so once you do that, let's go forward with, okay, that's the next question for you. Okay, so you can simplify this particular solution, which you can now see. So you can simplify this. H and H
Yeah.
cancel, and we know that 12 is equals to 4 plus B. And so we get second equation. One is 1 equals to B plus C. The second one is 12 equals to 4 plus B. And therefore, with these two equations, you can easily find the
So
solution.
now you can solve.
That is the
Yeah.
value B and C. Excellent question, thinking and
Yes, sir.
application question based on this particular unit, which has
Yeah.
come quite a few times, and therefore it is in my videos. Now
Yeah.
you can always finish this question answering, but here is the next question for you from the same test paper, which you can see on the screen now. I'd like you to
Yeah.
find the solution of this particular question and tell me what is the solution. Find the value of c algebraically such that f of x is continuous for all real numbers. Sketch the function. Yes, please.
Yes, sir. So we know that the piecewise function is f of x is equal to 2 minus x squared when x is less than or equal to c,
Correct.
and it's just x when x is greater than c.
Correct.
So for f of x to be continuous for all real numbers, the
Yes.
two pieces must produce the same value for c. So
Correct.
we can go about it by
Right.
plugging in c and then finding it.
2 minus x squared equals to x, we'll write that equation and we'll find
Yeah.
the value of x, right? Because
Right.
at C this is happening, correct? So
Yeah.
basically at C, x will be replaced by C. So you have the equation 2 minus c square equals to c. And once you solve that, you get
Yeah.
your answer. Perfect. So that is how you are going to answer this question. Once you find your answer, you can actually easily graph this particular question. Is that clear to you?
Yes, sir. So you can have more than one value for that because it's a quadratic.
Yeah, you could have. So when you solve this, you have to figure this out, what you really get, right? So as you can see in the solution, c plus 2 and c minus 1 equals to 0. We do get two values, which is c is minus 2 and c equals to plus 1, right? So I
Yeah.
like you to check your solution because there are two values of c where this could happen and sketch
Yeah.
both the graphs, right? It says sketch the
Right.
function. Important point, Akshit, you are a brilliant student. In the question also, you'll find that functions, S is in the
Yeah.
bracket. Now, this is very critical. S is in the brackets. It gives you a hint that there could be two solutions for this particular question. You get the idea.
Right. Yeah.
And as you rightly pointed out at the right moment, we do expect quadratic equation to give you two answers at times. And that is what it is, right? So, perfect.
Yes, sir.
Good job. Now, it's a very common question to ask you limits from the given graph, and therefore I'm asking you this particular question.
Yeah.
From the question, can you tell me uh, what is the value, limit of the function? Part C, limit of the
Yeah.
function as x approaches 0. Tell me.
Yes, sir. I'd say that the limit does not exist
Why?
because the left hand limit's not equal to the right hand limit.
Both the limits individually, left hand, right hand, exist, but they are not equal. And therefore, in
Right.
this particular case, we have a jump discontinuity. Correct. So
Yeah.
that is absolutely right for you. Now here we have another question, which is based on rationalization, right? When you get
Yeah.
an indeterminate in the form of 0/0, then you have these kinds of questions, correct? So you could
Right.
always do them. That is not the question for you. I'll move on from here, but this is the question for you where I will like you to do this question with the method of substitution. So can you
Yes, sir.
answer this question using the method of substitution? How will you evaluate the limit of 1 minus cube root of x divided by x minus 1 when x is approaching 1? Tell me the answer, please.
Yes, sir. So we can let a variable let's say y equal to the cube root of x,
Correct?
and then isolate for x, which would mean that y cubed is equal to x.
Correct?
And then based on that, we can reform the equation with a new limit and then avoid
What is the
indeterminate.
new limit? Limit for y is what? When x approaches 1, y approaches what?
Y would also approach one, sir.
Perfect. And then you put that. And how will you factor this? And from 0/0 indeterminate form, how will you simplify it? Can you tell me that?
Yes, sir. You
You
can
got
use
1
the a
minus
cube
y.
minus
You
b
got
cube.
1 minus y over y cube minus 1. So how will you factor that?
You can use a cube minus b cube, right, sir, for the
What is the formula?
denominator.
Yes, yes. What is the formula?
Yes, sir. So it would be a cube minus b cube. So a minus b, a squared plus ab plus b squared.
Perfect. So that is how you're going to do. So you basically expand it and then write down your answer, right? So that
Yeah.
is what you're going to do. And if we use the variable u cube, remember one thing, you have to take care of this minus because 1 minus x and
Yeah.
1 minus x, so you get that particular answer. That is perfectly fine. So here is another test paper for you from where I have another set of questions, correct? So can
Yes,
you
sir.
please answer these true and false questions? I know it is solved, but still read the question and tell me the answer.
Yes, sir. Number one, true or false, justify your answer for each response. When you rationalize the numerator of root of x plus h minus x over x, the answer is h over x times root of x plus h minus x.
Hmm. So true or
Right. Sir, I'd say that the answer is false.
okay? Why?
Because without doing the calculations, I think how is h on the top, right?
H will cancel. Perfect. Great
Yeah,
job. Great job. Because when you do the rationalization, H has to cancel. Otherwise, there was no
exactly.
point of doing,
Yeah,
the whole thing. So it is 0/0. Mainly because there is a common factor. And the whole purpose of doing rationalization is to cancel that factor. So once you do that, H and H will cancel and you get something else. Definitely, H will never be on the top. And therefore, this is
Yeah.
false, right? Since we
Yes,
need
sir.
to justify, so you need to, solve and do this question. Perfect. Now, okay, just quickly answer other parts, please.
Yes, sir. So for the second part, we see they gave us a piecewise function,
Yes.
and they're asking it's not continuous at x equals to 4. So if we plug in 4, we see that they both output two different values, so that's true.
Okay. Next.
The limit as x approaches 2 of f of x equals 1 over root of x minus 2 exists. That's false because of infinite discontinuity, right?
Yes, because when you're checking the limit, the restriction on the function is that x is greater than 2. You cannot
Right.
approach the function from the left hand side. You get the idea. You
Yeah.
cannot approach the function from left hand side, and therefore it is false. So without even calculating, you could give that reason and find the solution. You get the idea.
Yes,
Oh,
sir.
the next question was wrong. So let me have that answer from you. Okay. Wait. So my students have been doing very well, and they've been always the best students in the school. Can you please answer the next question, true or false? The function f of x, can you read it? Where f of 3 equals to 2, with limit f of x, x approaching 2 from left side is equal to limit when x approaches 2 from the right side uh, of f of x is 4. So the limit at 2 is 4. There is no removable point of discontinuity. Now, with that statement given, is this statement true or false? Tell me.
Sir, what would be a removable point of discontinuity?
Whole.
Oh, a hole. Okay. So we know that the point 3 and 2 is on the graph, and when we approach f of x, so the left-hand limit and the right-hand limit are equal at 2 to 4, right?
Right.
So, um, so there would be no hole in this case, right? The function is continuous.
Okay. We are not sure about it. The thing is, there could be and they may not be. Correct? Because we we are given a point f of 3. We are not given f of 2.
Oh, f of 2. Okay, okay. Yeah.
That is one thing. Now, second thing
Yeah.
is that the function which they are showing, f of 3 has got a value of 2, right? So
Yeah.
f of 2, we could have 3 also.
Right.
The idea. I mean, we have at 2, we got value of 4. So the function is giving you actually the value at f of 3. So when you sketch the graph at 3, you are showing 2. That is not the value at 2, right?
Yeah.
So this function actually is continuous. Uh, so so there is no removable point of discontinuity, but there could be a removable point. There is a possibility there is a hole. Do you
Yeah.
understand? So
Yes, sir.
that is why a student gets confused. Not always. The question is
Yeah.
not true always. That is the point, and therefore this is false. You get the idea.
Yes, sir.
So it is kind of a trick question. Um, so important to look at it in this particular. You did not do derivatives so far. So, uh, okay, so you did not do derivatives so far. So we are leaving that question for now, right?
Yes, sir.
Derivative questions I'm leaving, skipping those derivative questions. So, but you've done this part, which is using first principle, determine the point at which the slope of the tangent line is 2, where the function is given to you as f of x equals to 3 minus 4x minus x squared. Can you please do this question and tell me the answer?
Yes, sir. So determine the point at which the slope of the tangent line is 2. So we can use 2 and then substitute that as y and then solve for the difference quotient, right, sir?
What is 2? Slope of the tangent line is true 2. So that means 2 is limit of that function.
Yeah.
F plus h minus. So can you please do and get me the answer?
Yes, sir. So, sir, in that case, would x be 2 or
No, x is not 2. You have to find the value of x. That is why I'm
right?
telling you to do it. So please read the question once again, Akshay.
Yes, sir. Given the function f of x equals 3 minus 4x minus x squared, Using first principles, determine the point at which the slope of the tangent line is 2.
So you need to find x and y value on the
Yeah,
graph of parabola 3 minus 4x minus x squared, where slope of the tangent is 2.
yeah,
Yeah, so you don't know the point. So now do it.
yes, sir.
So the instantaneous rate of change is the derivative which you learn in the next chapter, which I've written
Yeah,
as f prime x or f dash x in this particular equation. And this equation is the difference quotient equation. Using limits, we can find tangent on any curve, right? So
yes,
that's
sir.
what you need to solve for the given question and find the value of x where the slope of the tangent is 2, correct?
Yeah,
So do it and tell me.
sir, I got the point.
What is the point? Tell me.
1 and minus 2.
Great job done. So that is absolutely correct answer since we know the formula of derivatives, which is we'll use the power rule and write down the derivative for me
Yeah,
minus 2x minus 4. And when you solve, you get x equals to 1. And when you plug in 1 there, you get the right answer. You're absolutely right. So that is what this answer will be. And this is the method of solving the question, right? So we know the derivative or the limit, which is equal to 2, and now you get 2 is equals to minus 4 minus 2x, taking minus 4 on that side, right? And
yeah,
then you can actually solve this particular question, right? So that is
yes, sir.
how we are going to do this particular question, right? So as you can see the solution here, oops. Anyway, so you have understood, right? That is how you have to
Yes,
solve
sir.
it. I'll stop sharing this. I'll share the whiteboard and ask you more questions. So we are almost at the mid of this particular test. Now here is another very important question for you. I forgot the number of questions which I have already asked. So I'm just writing the question here, which is we need to find the value of b in this function where the
Yeah,
limit exists. So we have the function as limit of x squared plus bx minus 3 is equal over x minus 1 exists.
yeah,
Find the value of x. X equals to 1. Find value of b.
yes, sir.
Find. How will you do this question?
Okay, sir. So if limit x approaches 1 for that function exists, then we can't simply plug in 1 because it would yield indeterminate, right?
Yeah, 0 over 0 when you plug in 1.
Yeah. So would we have to go about factoring the numerator first and
That
then
do it. So
yeah,
numerator. So that means numerator. So let me write what you're saying, and that means the numerator should have factor x minus 1. Correct?
yeah,
So if x minus 1 is the factor in the numerator, then you have to basically find what the value of b is. Correct?
right. Yeah,
So factors. So x squared plus bx. What is the possible value of 3? When one of the factor is x minus 1. So you need to
yeah,
get 3, right? So minus 1 you get as one of the values. Only if you are doing 3 times minus 1, right?
yes, yeah,
The other value is x plus 3, right? You can
yeah,
expand this and then compare and find the value of b. You get the idea, right? So when you
yes,
expand
sir.
x squared plus 3x minus x minus 3, and that gives you x squared plus 2x minus 3, and that gives you that the value of b is equal to, because this is plus 2. Is it clear to you?
2. Yeah,
You get the idea. So that is how we could do this question. Again, I picked up this question since I had not told you how to solve such questions so far, right? So Akshat,
yeah,
I really know that you know a lot and you could have answered many questions very easily. And therefore, I asked you the questions which you are not prepared for so that I
yes,
can
sir.
prepare you for tomorrow's test, right? That's the whole idea. Now, here is another kind of question. I'm giving you the limit. You have to use the properties of limit to answer this question. When x approaches 4, for the function f of x is equal to 3. So this limit is known to you. I want you to find the limit of the function x approaches 4 for f of x whole square minus x square over f of x plus x. Can you tell me the limit of this function? When you know
Yes, sir.
the limit of the function when x approaches 4 is 3. Tell me, yes. What is the answer? How will you do it? Tell me.
Yes, sir. So you said that the limit of the function when x approaches 4 is 3, right? So we know that the point 3 and 4 and 3 is on the in our scenario. So if we plug in f of x as 3 at the top and then x is 4, we can evaluate the numerator, right?
No. You need to use properties of limit.
Oh, okay, like f of x and g of x, that one, right? Sir?
Yes. So as you remember, this could be written as limit x approaches for f of x whole square minus
Yeah.
limit x approaches 4 for x square over limit x approaches 4 for f of x. You have to write this rather than
Okay.
getting the solution directly. That is the property of limits. You get the idea? So this is
Yes,
based
sir.
on the limits property. You will get one question for sure on properties of limit. You have to,
Yeah.
is that clear? Don't
Yes,
jump
sir.
to the solution, otherwise you lose 0.5 marks, and that is why I'm
Yeah.
doing it here. So the first part here, you know the limit is 3. So in that case, it is 3 square and minus x square. That is also 3 for you, correct?
Yeah.
It is approaching 4. So it is 4 for you. Substitute the value of x as 4. F of x limit is 3 to you plus the limit of x will be substitute 4 there. You get 4. Do you see that?
Yes,
That
sir.
becomes your answer 9 minus 16 over 7, correct? So
Yes.
get this negative. What do you get? What is 9 minus 16? So 16 minus 9,
-1, sir.
huh? 9 minus,
-1.
oh, okay. So you calculate. Yeah. So perfectly fine. So that is how you are going to answer this particular question. Is that clear to you?
Yes, sir. Clear. So I have to show that the limits for each part, right?
Yes. So
Yeah.
the properties of limits is so take look into your book exactly few more examples
Yeah.
based on how do you do questions related to showing properties of limits. Is that okay?
Yeah.
Great. So I'll clear the screen, and here is the last question for you, which is similar to one of the questions I had asked earlier. Think this is a part of a circle. Is it okay?
Yeah.
This is a part of a circle, right? And we have this point as 3. Okay.
Yeah.
Now, so this is a semicircle.
Yes.
Okay. Now, this is a semicircle. I want you to find uh, the uh, the limit. So tell me, what is the limit of this function when x approaches 3? Limit when x approaches 3 minus.
Yeah.
Tell me, answer first.
Yes, sir. So since this is a semicircle, right, it would be a square root function if we were to actually write it in function notation, right? Square root of 9 minus x squared.
Yes.
So the limit when x approaches 3 would be 0, right?
Very good.
And then for 3 negative,
No, that is not 0.
oh,
Yeah. For 3
does-
negative, it is 0 because you could approach from the left hand side, correct?
okay,
So
but
this does not exist.
right, because you can't
You
approach.
cannot approach from the right hand side. That's the idea.
Yes,
So
sir.
I gave you the graph mainly to have a visual look and understand.
Yeah.
Yes, if you go from the left hand side, then clearly you are approaching zero. Yes, I agree with you, right? However,
Yeah.
you cannot approach this function from the right hand side, and therefore the limit when x approaches 3 from right hand side for f of x does not exist. Since that limit does not exist, the limit at 3 also does not exist. Correct?
Yes, sir.
So
I
that is
completely
how.
forgot to check the right side.
Yes, you have to check from both the sides
Yeah.
to get the limit of this function. And now we could actually extend this question to give you find the equation of line equation. So now the question, which is a bonus question for you, is equation of normal at x equals to 1. So
Yeah.
that you understand how will you do this? Find the equation of normal at x equals to 1. So at somewhere here, there will be x equals to 1. So how will you do it? Explain.
Yes, sir. So, sir, when we say equation of normal at x equals to 1, right, would that mean that the line cuts vertically through x equals to 1?
Now, so then you know the tangent here, right?
Yes.
The slope of the tangent is, let us say, m. Then slope of the normal at this particular point will be minus 1 over m, correct?
Oh, okay. Yes. Negative
When you plug
reciprocal.
in 1, you know the value of y, right?
Yes.
So 9 minus 1 is 8, square root of 8, right? And then once you know this, you can use the formula y minus y1 equals to m times x minus x1
Nice. Yeah.
and find the equation of normal. But remember, your slope m will be negative reciprocal since we are looking into it as a tangent, right? You
Yes,
get
sir.
so you can do that as a part of a question later on. So does it make
Yes,
sense?
sir. Yeah.
So we'll stop. It was a very well done job. And I'm sure with this preparation, you should definitely get very close to 100 this time also. Can you please
Yes,
summarize
sir.
the work from the test paper for me?
Yes, sir. So today's one-on-one mock test was very different from Nelson because the questions are very like similar in the textbook, but the very few questions that we did today have really solidified what I've learned from in class with you and through the textbook, of course. And questions such as like the ones where we have to just now the semicircle one, the constants where we have to find, I think they'll definitely come in the test. So it's a good practice for me as if I do it now, I'd rather make mistakes now than in the test. So
That's
I
good
think
true.
it's
That's good true.
prepared me.
Beautifully said and summarized. All the best to you. And these were the gaps which I actually filled because I know
Yeah.
exactly what you don't know. So I try to fill those gaps so that you're 100% ready for the test, right? So
Yes,
go
sir.
ahead. All the best and share the result with us later. Okay?
Yes, sir, for sure.
Thank you and all the best.
Thank you so much, sir. Bye.
You can always join my classes by writing to me on the email address given. I can be part of your success story and build strong foundation to ensure bright future.